Okay, so chapter 7, permutation and combination. So I already separate them into 3 parts. So this is part A, permutation of n different object. Okay, so how many different ways to arrange the letter A, B, and C? So the first method, let us try to list down all possible answers. So if let's say you start with A, then it might be A, B, C, or you can have A, C, B. If you started with B, you might have B, A, C, or B, C, A. So B, C, A. Or if you start with C, you can either have C, A, B, or C, B, A. So the total number over here is equal to 6. So this one can be quite easy if we simply have a few letters. Otherwise, it can be a bit tough. Okay, so let us go to the second method. So since we have 3 different letters and we want to arrange all of them, we can say that we are using 3 factorial because we want to arrange all 3. Okay, so this is the second method. Use the 3 factorial and you know that this is actually equal to 6, which is similar answer over here. So the third method, since you know that you have 3 letters and you actually have 3 positions to it, you can actually use 3p3. What do we mean over here is that out of 3, we are going to arrange 3. So out of 3 over here, we want to arrange 3. So we can also use 3p3. So this is also equal to 6. So the fourth method is something that we have learned in secondary school where we are using the box method. So draw the box. We have 3 letters, so 3 box. So how many choices for the first box? So since this is the first box, we are going to have 3 choices to it. So either A, B, or C. So 3 choices. So I'm going to write down 3 over here because I have 3 choices. I can use A, B, and C. The second one, since I already choose 1 in front here, this one will be left with 2 choices. So there will only be 2 choices here. And over here, since I already put 1 in front, 1 in the middle, so that means at the end, I only have 1 choice. Therefore, this is 1. And then, of course, we got to do 3 times 2 times 1, which is simply equal to 6. Okay, so what I have done so far is simply showing you that all these 4 methods will come out with the same conclusion. But I will say that the first method is only possible if we have a few numbers or a few things to arrange. The second method will be quite useful if we want to arrange everything at the same time. The third method will be quite useful for us to see how many things do we have and how many things do we want to arrange. The fourth method will be quite useful if we have some condition to it. Okay, so how many ways to arrange all the letters A, B, C, D, E, F, G? If there is no restriction, that means we are going to arrange everything. So 1, 2, 3, 4, 5, 6, 7. So you can either use 7 factorial. So this is 5040. So if we refer to the previous slide, I'm not using the first one because I have 7. So it can be quite tedious for me to list down all the possible outcome. So I simply use the second step, which is 7 factorial. But of course, you can also use 7p7 because out of 7, we are actually arranging all of them. So 7p7, which is also 5040. Or you can have a few box for them. So 7 letters, that means 7 box. Oops. So 1, 2, 3, 4, 5, 6, 7. Okay, so over here we have 7 choices. 6, 5, 4, 3, 2, 1. So it will be 7 times 6 times 5 times 4 times 3 times 2 times 1, which is simply equal to 5040 ways. Okay, so the second one, we are still arranging A, B, C, D, E, F, G, but this time the vowel must be together. So firstly, let us determine where is the vowel. So A is the vowel, E is also the vowel. Since the vowel must be together, so let us do one group for them. So this is the group where I put the vowel together, A and E. And then we have B, C, D, F, and G. So when we want to arrange them, firstly we got to consider this as one group. So I will have 1, 2, 3, 4, 5, 6. So that means 6 different things to arrange. And then inside this group, I have 2 different arrangement because this is 2 letters. So it can either be AE or EA. So this is 2 factorial. So 6 factorial because I have one group, and B, C, D, F, G. So altogether we have 6 things to arrange. So 6 factorial. And within the group, I have 2 factorial because I can arrange the thing in the group. So 6 factorial multiply with 2 factorial. So this is 1, 4, 4, 0. Okay, so now again we are arranging A until G, but now the vowel must be separated. So A and E are the vowel and I must separate them. So that means we can arrange the consonant first. So arranging B, C, D, F, G. So we are going to arrange the consonant. Hence it will be 5 factorial because we have 5 different places to it. However, for the vowel, since we must separate them, we must put them somewhere in between the consonant. So I can put the vowel here, 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 or here. So I can have 1, 2, 3, 4, 5, 6 different places for the vowel. But out of 6, I only have 2 vowel. So that is why it's going to be 6B2. So 5 factorial multiply with 6B2. So this is 3600. But of course, there is actually a trick over here. If the vowel must be separated, it also means that the vowel must not be together. So just now we already calculate the number of ways so that the vowel must be together. So we can actually minus them. So we can take the without restriction. Okay, so it can be without restriction minus the vowel must be together. So this is 5040 minus with 1440, and you will get the same answer, which is 3600. So we actually have 2 different methods for this one, depending on how you want to answer the question. Okay, so this is a few conditions. So we have to start with A, but we must end with B, and we must arrange everything. So let us do some box. 1, 2, 3, 4, 5, 6, 7. So I already say that I must start with A and I must end them with B. So I only have one choice over here. Definitely need to start with A, and then definitely need to start with B. However, inside here I have 5 different places and another 5 letters. So I can use 5 factorial to it. So it will be 1 multiply with 5 factorial multiply with 1. Okay, so this is equal to 120 ways.